Welcome to the course in Experimental Structure Dynamics. This presentation will deal with structure dynamics. What is structure dynamics? What is experimental structure dynamics? And what is the difference between experimental and theoretical structure dynamics? If you Google structure dynamics, then you will find in Wikipedia, for instance, that structure dynamics deals with the behavior of structures subjected to dynamic loading. In this presentation, we will give some examples on this to illustrate what structure dynamics is. It may deal, for instance, with deformation of a structure when it's subject to dynamic load. Consider, for instance, a car running over a bumpy road. If the speed is low, then the car will travel over the road surface more or less without deformation. The only deformation will be due to the gravity forces. If the speed is high, then the wheel suspension system will be deformed and the wheels will move relative to the car body. So we will get a vibration, internal vibrations in the car. It can also deal with stress. If the amplitudes, the vibration amplitudes is large, then it may happen that the wheel suspension system is subject to large stress-strain variations. And it may even be so large that they may lead to failure. We can also talk about resonant response in structure dynamics. At some speeds of the car, the amplitude, the vibration amplitude will be very large. And that is what we mean with resonant response, resonant vibration. And that may of course lead to poor comfort for the passengers and driver. It may lead to poor control of the car from the driver's side and accidents. And we can also note that different critical speeds lead to different deformation shapes. So each structure has a set of critical conditions where which corresponds to different unique deformation shapes. In the car case, for instance, it might be rotation, or like we showed before, it can be translation, or it can even be bending of the car body. So structure dynamics tries to give an answer to some questions regarding these topics. First of all, how does a structure respond to a specific dynamic load? When the car is run over this bumpy road, then there will be a dynamic force, interaction force between the road surface and the wheel sets. So how does the car respond to this dynamic force? So given the road surface profile and the speed, how does the car vibrate? At what conditions do we get resonant response? So given the road profile, for instance, at what speeds is the response resonant? And as I mentioned before, there's not one single critical speed. There is several critical speeds. And to each speed there is a unique deformation shape. Next question is, are the resonant responses critical in some respect? For instance, is the amplitude at resonance too large so that well, the passengers or driver get sick? Can it even be so high that the car body comes in contact with the road? Or is the wheel suspension system damaged? Another important question then is naturally, what measures can be taken to avoid these critical responses? Can we increase the damping of the damper in the wheel suspension system so that we can reduce the response amplitude to acceptable levels? Is it possible to change the mass and stiffness properties of the car so that we shift these critical speeds to a safe region, to an interval where we do not use the car? In theoretical structure dynamics, we use theoretical methods, for instance, finite element methods, to analyze the structure response to dynamic loads. In finite element methods, you model the car, you divide it in elements, like this, for instance, and you state the equations of motion for each element and assemble them to the whole car, and then as a result you get a system of equations like this, with a mass matrix, the damping matrix, and the stiffness matrix, and the external exciting forces. And W here is, of course, the displacement of the node points between the elements. And this system then can be solved in computers to analyze, well, and the result then will, of course, be the displacement of the car body when it's subject to external forces. In experimental structure dynamics, the procedure is a bit different. There we use measured data to determine the structural dynamic model, which we then use to analyze the structure response to various kind of dynamic loads. So once again we have the car, then we place accelerometers in various observation points, and then we excite the structure, the car, with, for instance, a hammer, an impact hammer, and we measure the force that we excite with and the responding accelerations in the observation points. From these measured exciting force and responding accelerations, we can determine a dynamic model that we then can use to determine the responses to various kinds of exciting forces. So with this dynamic model, we can in the computer simulate the car's dynamic behavior when it's subject to various kinds of exciting forces. In practice, it's very common that both experimental and theoretical structure dynamics is used to get reliable, true results. So very often they are combined. And for instance, you start with a finite element model, and then you use an experimental model, some measured data to tune sort of the theoretical finite element model.